Hi, my name is Gerardo Franco. I'm an aerospace engineer, and today we're going to teach you how to design paper planes by thinking like an aerospace engineer. Based on where I grew up and my childhood upbringing, I would have never thought I would be an engineer. I was living an ordinary life, just like you, being a kid. And on top of loving to skateboard and ride my bike and play instruments, I absolutely loved art. It was something that I was naturally good at. Engineering never crossed my mind. Science and math really didn't interest me at an early age. From middle school to high school, I wasn't the best student. I wasn't doing very good in my classes, mainly because I didn't have the biggest interest in doing well in school. I really did not study well. I failed a lot of classes, retook math, just was not really interested in pursuing my education seriously, where I really had no options when I graduated high school. And so that really only left me with going to a community college where I was given a second opportunity to do better. Having been a bit disappointed with my performance in high school, I said, well, I'm gonna go to the community college, start from zero, and work hard to build myself back up. Eventually, I found the world of engineering, which was so exciting for me. It really combined a lot of my interests. I learned that through engineering, I could still practice art through a scientific viewpoint. And so from my community college, I transferred to UCLA and studied mechanical engineering. And there I got my first job working as an aerospace engineer. And it was so exciting. I absolutely loved aerospace engineering, and I kept going from there. The really cool thing about studying engineering is that you get to work on a lot of cool hands-on projects. You're not just studying all the time. You get to break things, design things, work with others, and try different and all sorts of fun, cool, exciting projects. Everywhere you look, you'll see the work of an engineer. From the screen that you're looking at right now, that was designed by an electrical engineer. The roads, the bridges that you drive across, those were designed by civil engineers. The car, the gasoline you put in your car, has a lot of chemical processes. That was designed by a chemical engineer. Engineering is all around us, from your phone, the toys that you use, it's everywhere. So you might think that engineering is out of your reach. You may not think that you're fit to be an engineer because you probably think you're not smart enough, or maybe you don't like math enough right now. But really, everybody should try engineering. It's really for everybody. There's a different field out there that may pique your interest. Look at me. When I grew up, I had no idea what engineering was. I wasn't very good at math. I really didn't know how things were made. But as I grew up, got more involved in school, I discovered engineering, and it has been my absolute passion. And I would highly recommend everybody try engineering, because kind of like there's different flavors of ice cream, there's different flavors of engineering, and there's one right for you. I didn't have the best background growing up, but I was able to complete my engineering degrees and land a job working on NASA satellites. If I can do it, so can you. So now that you learned a little bit about me, let's go inside and we'll learn a little bit more about how aerospace engineers think. And you'll be able to apply what you learn to build your own paper plane. Let's go. So, what do aerospace engineers do? Well, they build rockets, they build satellites, rovers. One of their most phenomenal projects would be designing the airplane, which helps people travel really far distances, such as from LA to New York, across the entire US, fast. So now that we know what aerospace engineers make, let's look at how aerospace engineers think so that they can design planes, rockets, and all that good stuff. So As aerospace engineers make these planes, they have to keep in mind a lot of natural forces that they encounter when flying in the air. So we're gonna look into these forces, break them down together. There's 4 main forces that are acting on a plane at all times. The first force is one that we're all very familiar with, and that's gonna be the force from weight. Everything has weight. You have weight, I have weight, everything that we see has weight. And so what weight does is it keeps us on the ground. Weight also acts on airplanes. Let's go into our second force, and that's going to be thrust. So thrust, this is what drives our plane forward. And thrust comes from our engine, so our source of energy and our source of motion. One thing to keep in mind is weight always exists, whereas thrust, we have to actually apply energy and apply effort to get the plane to move forward. Let's look at our third force, drag. And drag is something we're all very familiar with. For example, picture yourself in a moving car. And you stick your hand out the window. You feel air resistance. Now that air resistance is preventing your hand from going forward and actually pushes your hand back because it's resisting the motion of where you're trying to get to. And if our motion is to the right, then our drag is going to be against that, going to the left. So drag actually exists back here. We're going to label that force. For our fourth force, we're going to talk about lift. So lift is our fourth and final force, and it acts to get the plane off the ground. So ask yourself, what do all planes have in common? All planes have wings. So wings are shaped in a very specific way so that when the plane is moving at the right speed, they create lift. Let's draw the basic shape of a wing. Looking at it from the side, we're going to draw the side of the wing, and this shape has a specific name. It's called an airfoil. And so if you draw a line down the middle, you'll notice that the top of the wing is a little bit more round, and the bottom of the wing is a lot more flat. So this is the specific shape that gets us off the ground. Wings move through the air. So we have air passing above and underneath the wing. We have airflow above and underneath the wing. We have air molecules at the front of the wing that are traveling together, and they will need to travel above and underneath the wing and meet at the back of the wing together as well. This happens by having the air molecules travel above the wing faster than underneath the wing. To understand airflow underneath and above the wing, let's use a real-life example. Let's say you and your friend are running a race. So this is you, and this is your friend. And you're both running a race, and you start at the same time, and you want to get to the finish line at the same time. But let's say your path to the finish line is different. Let's say it's a lot more curvy and a little bit longer than your friend's path, which is just a straight line. If you're running the race together, you start at the same place, and you want to end at the same place together. But if your path is curvy and longer, for you to start and end at the same time, you're going to have to run a lot faster to catch up with your friend just running in a straight line. So since you're moving faster here, our air molecules up here are going to move a lot faster so that they can start and end at the same time. So you have air molecules at the front of the wing. If your air molecules are going over the wing and they're moving a lot faster, you're going to have air molecules here, whereas the air molecules underneath the wing are going to be moving slower. Therefore, you're going to have a more densely compacted count of air molecules underneath the wing than above. Since our air molecules are moving faster, they're spread out thinner and there's fewer. Because we have more air molecules underneath the wing, we actually have a pressure difference from underneath the wing to the top of the wing. And because of this pressure difference, we have a lot more pressure underneath than on top, causing our wing to experience lift. So now we're outside in front of a plane to see the airfoil shape firsthand. So you can see there's a lot more surface area for the air to travel on top than there is underneath. And this is the shape of an airfoil, which gives us lift. All right, so now that we are familiar with our four forces, let's take a look at how they work together and how they interact. So we have our lift, thrust, weight, and drag. Let's see what happens if we take away lift. What do you think is going to happen when there's no more lift on the plane? If we remove lift, we're going to have drag, weight, and thrust still acting on the plane. But without lift, what the plane is going to do is it's actually going to start dropping. Here we are in Torrance, California at the airport. We're going to show you the controls on the whiteboard, but actually also inside of a plane so that we can show you how pilots use these controls to maneuver the plane and have it go wherever they need it to go. All right, so we have our different control surfaces on a plane. We have our ailerons, our flaps, our elevators, and the rudder. So let's see what happens as we change all of these around. The first surface that we're going to go over are the ailerons, located on the outside of the wing. Our ailerons are actually used to turn the plane. And you're probably wondering how. Well, let's get into this together. Here we're going to draw the plane as we're looking from the front. Here we have our plane. And our ailerons are used to turn. And so they go down and up in opposite directions. So if we have our aileron over here go down, we're going to have our aileron go up over here. We have here the aileron going down, and it's going to change the surface of our wing. And we see how the wing shape really affects our lift. So if we have our aileron down here, we have the side of our wing looking like this. We have the airfoil. And if we have our aileron going down, we can notice that the shape of the wing has changed, making the wing a lot longer. Whereas in this case, if we have the aileron going up, we have a different shape over here. In this case, with the aileron up, it actually makes our wing a little bit shorter. Based on how these are drawn, the shape of the wing is different. The aileron is down in this case, and the aileron is up in this case. And because we have a different shape on both sides of the plane, then our lift is going to be different. So because we have airflow moving down this wing, going down a longer top of the wing, we're going to have lift in this case that is more lift compared to this side of the wing, where the travel distance of these air molecules here is a lot less than on the other side. We're still going to have lift, but it's going to be a lot less. And because of that, this wing is going to want to move up more so than this wing. And what ends up happening in that case is we're going to have a roll. We're going to have a roll in this direction. Let me show you what that looks like on a plane as it's moving through the air. So we have this aileron here down and this one up. So as we have these in opposite directions, we're going to have the roll of the plane. And as it's moving forward, what's going to happen is it's going to want to turn. It's going to turn this way. Come on in and join me inside of a plane. The first control surface we're going to look into is controlling the ailerons, which we control with the yoke, which is very similar to the steering wheel of a car. And we're going to use this to turn the ailerons on the plane. So if you turn left on the yoke, you'll make the plane turn left, just like turning a car to the left if you turn the steering wheel to the left. You turn the yoke to the right, and you'll turn the plane to the right. So now, if you take a look outside of the plane, you'll see how the ailerons are moving in opposite directions. Let's take a look. All right, so now let's look at our next control surface on our plane. We're going to look at the flaps, which are located closer to the inside of the wing. And a big difference between the flaps and the ailerons is the flaps go up and down together. So they move the same way. They never go in alternate directions like the ailerons. They actually only stay together. So you're probably wondering what the flaps do. Well, let's actually get into that on the whiteboard. So like we described before, the shape of the wing really affects the flight of the plane. So let's see what the flaps do and how it affects our flight. Here we have our plane. We're looking at it from the side. And so what ends up happening with the flaps is they really extend the length of the wing. So flaps exist for two main reasons. They actually slow us down, but they also provide lift. Now let's see why that happens. So the flaps, as they go down, they increase the length on top of the wing. And so if we increase the length of the wing on top, well, as we saw earlier, when we increase the length, we get a lot more lift from the wing because our surface on top is larger than our surface underneath. And so when we have that different distance that air molecules have to travel over, it creates a pressure difference which causes lift. So we have a greater lifting effect with our flaps down because our distance is greater up top, causing our lift to increase. But you can probably imagine as we change the shape of the wing, we bring it down, now we have a lot more drag from all of these air molecules crashing into the flaps. There is more surface for air to crash into. Just kind of like when you stick your hand out of a moving car, you can feel the resistance, all of the air colliding with your hand and slowing it down. It's very similar to a wing. So now that we have the flap down, we have a lot more air resistance. And when we have more air resistance, we are increasing our drag. So it's actually slowing the plane down, having the flaps in a downward set. Now that we see what the flaps do, we have a lot of lift, but we have an increased amount of drag. And so when is the ideal situation to have lift and drag together? Well, pilots use flaps when they're landing. It's one of their biggest contributions to the plane design. So as they're landing, you need to slow down, so you want to increase your drag, but you still want to have your plane off the ground so that you can land on the runway safely. Now we're going to look at our next control surface, the flaps. We're going to flip the switch to bring them down. So now that we looked at the ailerons and the flaps, we're now going to move to the back of the plane where we have our elevator and the rudder. First, we're going to go over rudder. Now, rudder moves side to side. And let's say we have the rudder facing this way. As our plane is flying, we're going to increase drag on this side of the plane, which ends up causing the plane to turn this way. If we turn the rudder over here, as we're flying, we're going to actually turn this way because we have an increased amount of drag on this side of the plane. Pretty cool, right? It's really cool to control the rudder because we control it with our feet. Watch, take a look. When I push my foot to the left, it'll turn the rudder to the left, causing more air resistance and drag on the left side of the plane, which will turn the nose to the left. If I push with my right foot, it'll turn the rudder to the right, causing more air resistance and drag on the right side of the plane, causing the nose of the plane to turn right. Lastly, we have our elevator. So if our plane is flying straight, changing the direction of our elevator will help the plane either go down or go up. And that's called the pitch. Our last control surface is going to be the elevator, which we control with the yoke. But instead of turning the yoke left and right, we're actually going to pull. So we grab the yoke and pull the yoke towards us to bring up the elevator, which will also cause the nose of the plane to go up, and push the yoke away from us to bring down the elevator, and the nose of the plane will go down.